So good afternoon to the audience of the LinkedIn Live. We are here in the event called Building an Ecosystem for Multi-Bank Financial Crime Prevention today. This is a part of the Mobey Forum expert group. We are here present at Mobey Forum. The group is gathered here. Today we have a special event similar to the one that we had in Helsinki 6 months ago, where we tried to get the expert from all around the world that can help us to understand better some of the aspects of privacy enhancing technologies. In this case, we are focusing especially on the multi-party computation and on homomorphic encryption. And so I would like to start the meeting by introducing myself. I'm Amir Tabakovic. I'm the chair of this expert group. We are part of Mobey Forum, which is a global non-profit industry association empowering banks and other financial institutions to shape the future of digital financial services. And we started our expert group some 2 years ago, focusing on privacy enhancing technologies, which at that time was not at all as hyped as it is now. In the meantime, we published several reports on privacy enhancing technologies. I welcome you to download it. They are open and accessible from the Mobey Forum website. Today, we have a very exciting topic. We are not talking about privacy enhancing technologies, but rather a specific use case. The use case is financial crime prevention. And the most interesting aspect today is how can banks work together to improve and become more efficient, improve their analytics, and increase the success rate of preventing financial crime. Today we have with us Ivich Hoffman from ABN AMRO. She will present in a minute. We'll start the presentation of her take on multi-banking financial crime prevention. Then we will have a joint panel with Peter Langenkamp from TNO and Manuel Capel from Inpher, and also Ivich Hoffman. And in the last time, it's not only about talking, it's also seeing it is believing it. We have the unique opportunity to look into the demos of 2 different solutions which are focusing on the same problem, and which is collective sharing and providing informations for financial crime prevention. I encourage you to ask questions in the LinkedIn Live and leave us your comments. And I would like to hand over to Ivich Hoffman for her presentation. Ivich, the stage is yours. Thank you.
Yeah, thank you very much. I will start sharing my screen. So I've prepared a presentation. Please, do you see my screen?
Yes, we do.
Great. Well, let me start by introducing myself. I am Ivich Hoffman, and I've been working within ABN AMRO for over 20 years now. And the department I'm working in is detecting financial crime. That's DFC stands for. And the name of my department is Connect. So we really believe that making connections with other parties and collaborate with other banks or public parties is the future of detecting financial crime. So I'm really excited to tell you just a little bit more about why we think that collaborating with other banks is the future. And of course, you need some techniques to do so. And privacy enhanced technologies are essential in making that cooperation work. So if you see here the next slide, you see that on one hand, we as a bank, we have our obligations as a gatekeeper. So we have to detect potential financial crime, but also we want to play that role as a gatekeeper from a societal impact. Of course, we have to comply to the law. In Dutch, it's called the WWFT. And from society, there are high expectations to do so. And well, our department, Innovation and Design, which Connect is a part of, we have 3 pillars. I call it the golden triangle, because that's are the 3 main necessary ingredients to look at the future of detecting financial crime. One of them is artificial intelligence. The other, of course, is data, because if you have the right data, you can better detect. And the third one, I said it already, is collaboration. So regarding artificial intelligence, we have within ABN AMRO a data science innovation team, which makes models to better do transaction monitoring. But I'll show you why it's important to do that not alone, but to collaborate. Because once you collaborate, you see more. And if you bring data together on a right way, you are able to see patterns you cannot see alone. Because criminals are very smart, and they know that within a bank we can only at this moment see the transactions and the patterns within one bank. But of course, our gatekeeper role is based on the follow the money principle. So if we want to follow the money, we have to collaborate and to bring data on a good way, on a privacy enhanced way, together to see more. The next one is collaboration. We have to learn from each other. And also we have to learn with each other. Like I said, we are working on advanced analytics, on models, for example, based on anomaly detection or outlier detection. And once we have, as ABN AMRO, we have developed those techniques, why should we keep it with our own bank? Because we have the same goal, and that's making the Netherlands a safer place and keeping a safe financial system. So if you collaborate with other banks, you can learn together to create new models and learn from each other's expertise. The third one, the reason why collaborations is so important, and you know that within the Netherlands we have a really collaboration tradition. In Dutch it's called poldering. We always work together with several parties to get the best out of it. One standard, well, one of the burdens, issues, or complaints we receive from clients that every bank asks its own questions to clients, slightly different than another bank, needs its own data requirements, but still we are explaining as a bank the amendments of the law into policy standards. So why not team up and making one standard? So that's why, together with ING and Rabobank, we have decided as ABN AMRO to make one KYC taxonomy, so that we ask the questions to the clients, the same questions, asking for the same data, do the same validation. And of course, sometimes we need more questions to be asked because we have our own risk appetite. But at the same time, one standard is the basic and is the norm. And the last important reason to collaborate is we are stronger together. We have, as banks, we work together in the chain. And you can call it the detection chain, together with the police, with the ministry, with the several, the financial intelligence unit, of course. And we are as strong as the weakest link. So that's why every link should be strong. And once you can collaborate with other banks, you can have that robust link together. So that's why, for me, these are the 4 reasons of collaboration. And that's why we need techniques to support that collaboration, because we have several kinds of partnerships at this moment. We have public-private partnerships, like special task forces, which are focused on special cases, special criminals. We were working together with the governmental parties, together with the public, so public and private parties. And as you see also that we have some cooperations with banks. One of the most known cooperation is TMNL, Transaction Monitoring Netherlands, and I will focus on that later. But one of the most promising cooperations is a project we do together with TNO, with other banks, and also with TMNL. And well, that cooperation is based, it's called the Alliance of Privacy Enhanced Technologies, multi-party computation, and it really brings together the golden triangle, as I mentioned. So advanced analytics, privacy enhanced, data, and multiple parties. And I think our biggest challenge is to really to make to know when do we have to look at the privacy law, and when do we have to look at the WWFT, because there's a gray area between those those 2 legislation. And if you look at our privacy lawyers within the bank, they say, well, there's only one solution, and that solution is called multi-party computation. But let me slightly get into the TMNL. I don't know if you've heard about it, but it's unique in the world, and it's a cooperation which in fact is already there. So 2 years ago, after a year of preparation, TMNL, Transaction Monitoring Netherlands, has been founded. It's a cooperation between 5 banks, and we have our ultimate goal is to take over transaction monitoring of the 5 banks. Yeah, because together we can see more, we can be more effective, but also at this time, if we look at transactions within ABN AMRO, we look at one side, and for example, ING is looking at the other side of the transaction. And once you bring it together, you can you have to look at it only once, and you can see the pattern in a broader perspective. So but that is our ultimate goal. At this moment, we are effective on top of monitoring. On top of monitoring, so we have our own monitoring within the banks, and on top of monitoring within TMNL. And we bring together data, pseudonymized, and on that data, we build models to gain multi-bank alerts. Well, last year we have proven that yes, we are able to bring the data together. Yes, we have been able to match the data of the different banks, pseudonymized. And yes, we have made some interesting alerts and did already some SAR filings. So it's really promising. But we have 5 pillars which are very important for the success of TMNL. And one of them is, of course, the cooperation between the banks. Well, that already 3 years we work together with the 5 banks, and although we have it's not always easy, because we have the same vision that in the field of detecting financial crime you cannot operate alone. We are still there, and we're still investing in TMNL. And then the law. The law is we need an amendment of our law to get to that ultimate vision of outsourcing transaction monitoring and adding personal banking data. And to be honest, it's not easy to get the law changed. There is already an amendment of the law, but like yesterday, there was our Council of State said, well, we have doubts to change the law because of privacy issues. Aren't you, is this not the start of, for example, mass surveillance? And is the privacy well deserved enough, preserved enough within TMNL? And of course, it's insecure. We're not there yet, but it shows how important it is also to, at the same time, invest in privacy enhanced technologies. And that's why also TMNL is taking part of our Alliance for Privacy Enhanced Technologies as well. Because once we are able to use data, so we can combine data, but still do it on a privacy enhanced manner with analytics, I think then we are the most effective when it comes to detecting financial crime. So the other pillars, of course, is we are experimenting with a different kind of models focused on like community detection, so bringing patterns and in gathering insights. And of course, we do it on a data in a secure matter. And like I said, privacy is very important. So we all the time we work together with privacy lawyers. What data can we share? Because at this moment, TMNL is still bringing the data physically together, but pseudonymized. So what we hope for the future is that we are able to move on with TMNL, so we can really better detect, being more effective in finding the criminals, and at the same time also doing it in a privacy enhanced way. But we really believe, together with TNO, with other banks, and together with TMNL, that if you really want to create the future of detecting financial crime, you should do it with privacy enhanced technologies. And I know that Peter will give a demo on that part later. So I think I will keep it with this.
Thank you very much, Ivich, for an excellent presentation. Very interesting, because my personal feeling is that there are different initiatives right now starting in different parts of Europe, in different markets, but we don't talk enough about this. We have to be more present to raise this awareness that this is right now happening, and that also different very important pieces of the puzzles are getting together, as you really nicely show with these pillars, and that the privacy is one of the essential pillars to bring this to success. Thank you very much for your presentation. In respect of time, I would suggest that we start the panel immediately. And before, so you, our viewers, they already had the opportunity to meet Ivich, but I would also like to let the two panelists to introduce themselves. Maybe Peter, would you like to start?
Yes, of course. Because of time, we'll keep it short. But I'm Peter Langenkamp, a researcher at TNO, and I work mostly on the topics of secure multi-party computation and self-sovereign identity.
Thank you. Manuel?
Thank you, Amir. My name is Manuel Capel. I'm Business Development Director at Inpher for Europe. And I work mainly with Inpher's clients and helping them setting up the value proposition for their initiatives and setting up the project for successful implementations.
Thank you very much. So let's kickstart this panel with a question to Ivich. And what I would like to know is, do you think that you and ABN AMRO, are you representative for TMNL when it comes to this awareness and consciousness of that we need privacy enhancing technologies, or are still some members still kind of in this feeling that based on the fact that we have a legal basis by GDPR to process the data to prevent fraud, that we don't need additional technological additional technologies to do so?
Well, I'm convinced that we need those new techniques, because well, at this moment, well, we experience that squeeze all the time between privacy and the WWFT. So it's a gray area, because, well, at one hand we can at the WWFT we have like a legal basis to ask some more data and questions. But on the other hand, sometimes I get the feeling that the privacy and the GDPR is kind of a shield for the criminals. So we need some data to better detect and to detect the patterns, but we don't have access to that data because of the privacy. So it's really a difficult situation. And even our privacy lawyers say, well, we really need that privacy enhanced technologies to as a solution. And what my concern is a bit that well, you need to be clever and know that what are the privacy enhanced technologies, what they are about, how they work. And at this moment, our government is in charge of amendments of the law, and I really hope that they want to invest in their knowledge about these techniques.
So if I understand you right, the price enhancing technologies are helping us to draw the line between legitimate interest, and fighting financial crime and this kind of a mass surveillance, and it's
it's kind of a solution, because, well, once you can make use of the patterns without actually sharing the data, the privacy is okay.
Yes.
It's not a concern.
The next question is for Peter and for Manuel, and the question is that based on what we discussed in previously, and we saw also in Ivich's presentation, is that everything is circling around the secure multi-party computation. We also know that there are different other technologies that help us to do collective sharing and processing of data. There is confidential computing, there is federated learning, and so on and so forth. What makes secure MPC so omnipresent when it comes to financial crime prevention use case?
Well, I think, first of all, it's important to acknowledge that all of these technologies have their own place. Each can be useful for certain reasons, but MPC in particular, secure multi-party computation, I think speaks to the imagination. You can think of the calculation you want to perform, and now there's a way of doing that in a secure way. Techniques like federated learning allow for very interesting analysis, for example, keyboard prediction improvement and so on. But it's much more involved and to think of the protocol that you would want to implement. With MPC, you can ask, well, pretty much a novice at an organization, what is the calculation you would like to perform? And now we can figure out a secure way of doing so.
Yes, I also agree with that. Every privacy enhancing technology has a different purpose, and when you look at MPC, it has slightly different characteristics. So, for example, when you look at encryption-based PETs, such as homomorphic encryption, it's useful in some cases where you want to protect the data inputs while in transit. So already it requires that you are sending the data somewhere, but also useful when you want to protect the model. So you are able with this type of encryption to send the data to some place to be computed. And like this, the participant who has the model can keep it secret. Then you have another family, I would say it's confidential computing, enclave based. So you probably heard about data clean rooms and secure enclaves. And here again, it's the little bit the same, is that you have to send the data somewhere that it gets computed in some place that it's safe. But in both of these methods, at some point you have to send the data. What makes MPC or multi-party computation or secure multi-party computation is that it's not based on encryption per se, but it's based on mathematical security. You are sharing some triplets of data or some secret shares that are basically generated randomly. And this makes mathematical security in the sense that they cannot be broken. Even if you have infinite computer power, you cannot break the security of MPC. And by the same reason, with MPC, the data inputs, they stay in place. It's not required to send the data into a central location. And as such, the inputs are protected because they're not exiting the confidentiality perimeter of the bank, for example. So I think this is really the two main reasons why MPC is so omnipresent.
Yeah, thank you very much. So coming back to TMNL, example where you still have to provision the data, which is pseudonymized in a central, some kind of a central bucket. This is a challenging part. Now, if you have to get the permission for provisioning of customer data outside of the bank, that's a challenge which doesn't exist with the secure multi-party computation. No.
So are you asking me?
Yeah, it's an open question. So I guess that we can move to the next question. And this is again picking up where we just right now we stopped with talking about the internal processes at bank. And I would like to hear from Ivich. Your experience is, if you want to improve your financial crime prevention from the perspective of your own bank, there are different roles, different stakeholders within the bank which are involved in this process. We have information security department, we have data science team, we have legal compliance team. So how do this role play together when it's about, when we want to reach out to other banks and make this multi-bank cooperation happen?
Yeah. Well, for example, within regarding TMNL, there were expert groups organized with the different banks. So you had the lawyers together, you had the compliance advisors together, you had the technical specialists working together. And within ABN AMRO, we also had a group with the different expertises gathered. So I think the important thing is to have one goal, but also that someone of compliance understands how data science innovation works, and vice versa. And in my opinion, you need them all to be successful, because once you forget about the lawyers, you have no legal basis. Once you forget the compliance, you don't have processes. So in my experience, you really need to have them all work together, but also understand each other. because within compliance, they want to be compliant, in control, and they have to get the feeling of being in control. So they have to understand how, for example, anomaly detection models work. And so sometimes it takes some while to have a model in production, because every expertise should understand it and should approve it.
Yeah, I think I agree with that as well. And definitely with our clients, we see really cross-functional teams composed of lawyers, compliance experts, functional experts, so people who actually know about fraud detection, know about the patterns, and most importantly, data scientists, because they are the ones who are going to help with structuring the data, and they're going to help with building the better models at the end of the day. Whatever is the PET or the privacy enhancing technology that is used underneath, you need the data scientist to make it work.
So in the organizations that try to bridge the gap between business and data scientists, there is this new role of analytical translator, someone who has these interdisciplinary skills. Do we need privacy enhancing technology translators for the organization in the future?
I haven't thought about it, but it might be a good idea, because I think it's really key to have some persons in place who can make the translation. Because if you are really a data scientist and you talk about data science and you cannot translate it to other people who have other expertise, it's not going to work. So yeah, if we believe that collaboration is key in shaping the future of detecting financial crime, I think a person like that is key as well.
So I also think this is a very important point, because, well, I myself, I usually work on the technical aspects, but very important questions that still need to be answered are questions on the legal level. But in order for legal people with a legal background to answer those questions, they need to have some knowledge about the technology. They need to know what is happening, what exactly is or isn't being shared. And someone needs to be able to explain what I'm doing, let's say, to someone who has to figure those details out.
Manuel, do you see also your role or the role of your organization as this kind of a translator, someone who also helps banks and let's say multi-bank ecosystem to do this kind of a legal and technical assessment of this technology?
So yeah, that's a very good question, and I would say that it depends. It depends on the client. Some clients, depending on their level of expertise and the level of involvement, they might require some support from us, especially if they want to perform an audit of the solution, or if they want to really understand in depth what this mathematical security means, how data is actually protected. So we come and we help them. We basically train them and help them to understand how the technology works, and we also help them in the conversation with the regulator to make sure that everything is fine.
Sorry, and if I may add, also you need someone to be able to pick out the necessary and required technology. You don't want to make it more complicated than it needs to be. So there's lots of different privacy enhancing technologies that you can use to solve a certain problem. Sometimes secret sharing is the way to go with multi-party computation. Sometimes homomorphic encryption makes sense. Sometimes all you need is differential privacy or federated learning. And you need people to be able to make the distinction which technology is the right technology for this problem.
Yes, absolutely. So we see right now that there are different initiatives starting in Europe when it comes to this multi-bank financial crime prevention. What do you how do you see the future in the next 2 to 5 years in Europe? Do we see one alliance becoming the dominant one, or do we see different alliances joining their forces together? How the one side is the political one and the other is the technology wise, and do we also see also some kind of are we talking about making the technology interoperable in the future, so that even if you run different initiatives, you're able to collaborate on the wider scale? Because I think you also mentioned that you are right now with TMNL, you are trying to structure, define the data now which is collected. So can you, all three of you, give me some insights on that?
Sure, I can start on this one. So what we see from our point of view is we really see three types of clients. So we see clients that are coming together inside the same industry. So it's really a cluster of participants, let's say banking, insurance, or even automotive, and they are building between themselves an ecosystem of data because they have a common objective. Typically, what we are talking about here is fraud. So they come together, they want to collaborate with the data, they want to build collaborative models, so they come together as a, let's say, as an inter-industry group. But then we see other types of clients that instead of doing that, they, I mean, where the initiative is initiated by a central body. So it could be a regulator, it could be a central bank, it could be an interbank organization. And because they have this central place and because they have the relationship with all the other banks, then they will, let's say, orchestrate and take care of the initiative. So we see now two main initiatives in the market at the moment in the banking space that are happening right now. And then the third category, I would say, is venture or consortium based. And this is where one organization wants to do this initiative, and this we have also concrete examples. They create a spin-off, and that spin-off becomes their own independent entity. And the purpose of this spin-off is then to take the responsibility for the orchestration, setting the data partnerships, managing the data and the security governance, and basically to service the goal of the consortium. And then the participants, they have a role to play. Either they can be board members or they can be included in the data collaboration network. And at the end of the day, this new venture of the spin-off is going to monetize this, and depending on what the participant's role is, there will be a monetization scheme in order to make it fair.
Mm-hmm. How do you see it, Peter, from your perspective?
Well, I think you asked a lot of different questions, actually. One of the topics you mentioned was interoperability. That's something we are working on within TNO, trying to figure this out. In particular, we are looking into a standardized way of requesting protocol execution. So there's many different protocols you may want to execute, and how can we standardize this so that a protocol thought up by one party can easily be requested from other parties. Mm-hmm. In addition, so what do I think will happen in 2 to 5 years' time? I think more ready-to-use components will become available. So basically off-the-shelf solutions for readily identified problems. This is something we're currently working on in TNO's MPC lab, for example. So MPC solutions that have been built for other projects becoming open source. And if you know this is the problem we want to solve as well, then you can simply take those components. Another thing where I think major strides will have to be and will be made is where legal knowledge is concerned. Currently, there's a lack of jurisprudence. GDPR is still relatively new, so lots of questions are still unanswered, and I think a lot of progress will be made there.
Mm-hmm. Thank you very much, Peter. And Ivich, you started this event with your presentation, and you presented also partly also the vision for TMNL and also the other alliance that you're participating. What is your personal expectation? Where will you be in 2 to 5 years with both of these initiatives?
Well, of course, we hope that with TMNL that we are able to develop our strategy transaction monitoring also for single bank monitoring. But honestly, we don't know. And hopefully multi-party computation and our project is becoming the practice, because I do believe that the way we act our KYC and our client due diligence at this moment, it's all at this moment, it's about 20% of our employees are working in this field. So it's well, in my opinion, much too much. So I think that we have process automatization. We have hopefully we as banks are a professional link in the chain. And that means that with our supervisors, with our government, we have good conversation to tackle this problem together. So cooperation in that field and working together on privacy enhanced technologies to be as effective, but also as efficient as possible.
Thank you very much. So my personal impression is that although the topic sounds very technical on the first sight, it's all about the collaborations, no? Collaborations on different levels, collaborations between banks and technology providers, collaboration between banks and regulators or governmental bodies, and then finally the collaboration between the banks themselves. So I think this is a very interesting area, and we will continue to observe and also provide the platform within Mobey Forum for this kind of exchange. And I hope that we will be able to make some kind of a follow-up event, also bringing in some other initiatives in Europe, and hopefully we will be able to share the experiences. Thank you very much, Ivich, for your participation in the panel. Peter and Manuel still have the last part to perform, and that's, I think, also we are right now perfect in time to start with the demos. And I would like to ask Peter to share his screen and start his demo for TNO.
Thank you.
Thank you very much.
Okay, I think everyone can see my screen now. So I'll start off with a couple of PowerPoint slides, and then I'll get into the real demo. Yeah, so what I've been asked to show you today is our secure risk propagation protocol. And I'm standing in for Maribeth van Egmond today, who unfortunately could not make it. Yeah, the secure risk propagation protocol is being worked on within the research program Alliance for Privacy Preserving Detection of Financial Crime, collaboration between TNO, Rabobank, ABN AMRO, the Volksbank, TMNL, and CWI, Center for Mathematics and Computer Technology. And we're working on many different topics and challenges: synthetic data, an MPC platform, secure graph algorithms, amongst others, graph embeddings and secure risk propagation, and also looking into legal challenges that exist. And within this project, we're working on a pilot with 3 banks this year, where we want to test our protocol on real transaction data. Let's see if I can get the slides to move. Yes. So I think this was mentioned at the start of this meeting, that on the Mobey forum, some mini reports are available on technologies like the homomorphic encryption. And well, we have already heard about secure multi-party computation, which is a way for multiple parties to perform a calculation in such a way that the inputs remain secret and they only learn the output. Well, some people include in this definition only secret sharing. Some others also include homomorphic encryption in the multi-party computation, because you can use homomorphic encryption to achieve this feat as well. So within TNO, we typically include homomorphic encryption in secure multi-party computation. Doesn't really matter. The gist is we want to perform a computation in a secure way, keeping the input secret, only learning the output. And for this secure risk propagation, we've opted to use homomorphic encryption, one of the many privacy enhancing technologies. So to start off, let's get this out of the way. Yeah. Okay, so we have a transaction network comprised of 3 banks in this example. The blue nodes are, dark blue nodes are ABN, light blue is Rabobank, and green is the Volksbank. And the idea is that every account has a risk score associated with it, which can be based on cash history, the use of cryptocurrencies, money from or going out to high-risk geographies. And each bank is able to determine this score for their own accounts. In this picture, the bigger the node, the higher the associated risk score. And it's important to note that the picture we see here is simply based on synthetic data. Yes, sir. Well, now in this example data set, we've included a money laundering pattern. And what this means is that in a very simple example, some money is gathered. So multiple accounts are working together to funnel money to one central account. And in this example, the big light blue nodes and the green nodes have a high risk score, which was based on the previously mentioned factors. And they're all wiring money to one node at Bank A, at ABN. And now the idea is, using risk propagation, we would like to see that the risk score of this blue node also increases because, well, it's suspicious, isn't it? If one account is receiving money from lots of accounts with a high risk score. So this is what we want to see happen, but there's a problem. The problem is that the accounts are located at different banks. So the Volksbank, ABN, and Rabobank only see their own own network, only know the risk scores of their own accounts, and they don't know the scores of the accounts of the other banks. Because of privacy regulations, you would not want to share those risk scores in the plane, but we still want to perform this risk propagation. So the solution we've opted to use is using homomorphic encryption, and an important step at the start of the protocol is a distributed key generation step. Homomorphic encryption often uses public-private key solutions, where you have a public one key to encrypt your data and another key to decrypt the data. And in this case, with 3 parties working together, neither party should be able to decrypt the data on their own. Only when all parties come together, they should be able to decrypt the solution. And using this key distribution, we make this possible. Well, next, each bank will encrypt their risk scores. And because we're using homomorphic encryption, we're able to send these encrypted scores to the other bank, and the other bank is able to perform computations using these encrypted scores. The bank won't know the answers right away because it's all still encrypted. So a secure calculation takes place, and then we want to reveal the results, for which all the banks need to cooperate, come together to generate the key that's needed for decryption. And in the end, it will be revealed that this blue node has a high risk score associated with it. So we're able to update our view at ABN. So without further ado, I'll start with the real demo. Let's put this here. And full screen. So as mentioned, we'll have 3 parties for banks A, B, and C for short. And I'll start an instance for each of these banks. And it's important to note that while I'm running this on one computer currently, that's only because it's easier with sharing my screen. The protocol being used actually exchanges data as though I was using multiple computers. And we typically use this demo on multiple computers as well. Okay, so to start things off, we have bank A. I'll increase the size of the window slightly. And we want to import our account data. So we have knowledge of some accounts in our network. And well, as you expect, each account has a IBAN number associated with it. And we can see all the accounts in our own network, of course. And we can see some accounts at other banks, at Bank C, for example, and Bank B. The reason we can see these other accounts is because they have interaction with our own accounts. So money is flowing into accounts at our bank or going out towards those accounts from accounts at our bank. Finally, we have a risk score associated with each account in our own network. Next step is to import transaction data. And well, by including the transaction data, now we have the nodes of the network and the connections in the network, so we can draw the transaction graph. Quickly going back to, the network which we saw before. Yeah, so this is the whole transaction network, but Bank A can only see this part of the transaction network. So we have the transactions, and the transactions comprise information about the incoming, the source account and the target account, and the amount associated with the transaction. Well, next step will be to generate the crypto key material. As I mentioned, this is done in a shared way. So we need the cooperation of the other banks to do so. So the next step will be to ensure that the other banks are ready for this step as well. And to make my life easier, I've included an autopilot function, which means I have to press left buttons, but otherwise the banks will do the same as I just described. So import the nodes and import the transactions. And now we can see the view from Bank B. And if we look here, make it slightly bigger, we see that Bank B has 2 large nodes in their network, which are the ones with the high risk score, so 0.9. And all of the other accounts in here have relatively low scores associated with them. Going to Bank C, also import the data here. And the transactions, and we see the network as seen by Bank C, which again is different from the network as seen by Bank A. So the next step will be to generate the crypto material. There's a random component here, but usually it takes about 10 seconds for this to finish. And yeah, it's done. And now we're able to encrypt the initial risk scores using the keys that we just generated. And if I make this a bit smaller, then we can see what happens using the homomorphic encryption. So we had scores looking like this, and now they look like this. Well, as you can imagine, not much information can be gleaned from these numbers over here. But the nice thing about homomorphic encryption is that we can still perform calculations using these big numbers, which is what we'll do now. So we'll execute the algorithm, which means that a risk score at Bank A, for example, this node, will be updated based on the risk score of incoming nodes. And this will do again. So in the next step, the risk score of this node of Bank C will be updated based on the risk score of this node. And the updated risk score is used to update the score of our own node again. And this will do a number of times, number of iterations. I can check probably, 10 times with the current settings. And afterwards, we get the end results, the final risk scores. So if I execute this protocol, you'll see that the numbers will update. So they're still encrypted, but they have changed. And if all banks are satisfied that the calculations were done correctly, we can come together and we can decrypt, which we'll do now. So we see we have new risk scores. And if we switch to the other view, so this was the old graph, and the new graph looks like this. So what we see here is one of the nodes has blown up considerably. It had a risk score of 0.05 and is currently at 0.36, so a 7-fold increase, which is noteworthy and is probably warrants further investigation. Well, because we're running the demo and we also have access to the information of Bank C, so we can easily see why this is the case. Well, as I mentioned before, there were a couple of nodes with a high risk score in the network of Bank C. These two over here, both 0.9, and we can see arrows pointing towards this node at Bank A. So look at the hover, and if we remember this IBAN number ending in 939, and go back to Bank A, we see that that's the same IBAN number. So its risk score has increased a lot because of the high scores of the adjacent nodes. If we go back to Bank C briefly, we see these nodes had a high risk score, but we can also see that after executing this protocol, they have shrunk, they have become smaller. This is also an important factor. We don't want risk scores to only be able to increase, of course. If a account has at one point been flagged as suspicious, but it's only behaving in a normal way as you would want someone to behave, the risk score can also go down. So the incoming node from Bank C had a very low risk score, 0.001, and that's the reason these high risk score nodes have gotten a lower score after execution of the protocol.
Thank you very much, Peter. You're running out of time. I assume the demo is over. No?
Exactly. That was the demo.
Thank you very much. Very, very interesting. But we have almost no time to digest it because we have time for the next.
My apologies.
Yes, we will still have a video to digest everything in a slow-mo later. So, Manuel, the stage is yours.
Okay, I'm going to share my screen, Peter, if you let me.
Yeah, 1 second. Okay, you should be able to now.
Thank you very much. All right, so just very quick introduction about Inpher. We are a Series A company. We are based in Lausanne, Switzerland, but we also have offices in New York and San Francisco. We have approximately 30 employees. And most of our employees have PhDs, and they are some of the main contributors to cryptography and PETs. One of them is, for example, one of the main contributors to the homomorphic library, homomorphic encryption library. So one of the most widely used encryption libraries.
Manuel, do you go
yes.
to the full screen, maybe slideshow, because we see the entire screen.
Okay, let's try this. Is it better?
Yes, thank you.
Okay, so what our product is, it's basically a platform to orchestrate the different privacy enhancing technologies. At the core, we have a multi-party computation engine that allows to join the data together and perform machine learning algorithms to train models and in particular with fraud detection. But our technology is also used to generate synthetic data, is also used in federated learning use cases. And we also use fully homomorphic encryption, very similarly to what TNO is doing for inference of some models and for running, let's say, sharing data where the model has to remain secret. So just very briefly, I mean, I know that a lot of you are already familiar with how MPC works, but just in case, and for you to better understand the demo that will come after, this is how MPC works. Basically, we have a central orchestrator service that is sitting in the cloud. And based on the operation that we ask them to do, he's sending some computation instructions to the participants. And the participants have the data, let's say, in their secure enclave. As I said before, the data doesn't leave the security perimeter of each bank. Then the participants, they follow the instructions, and basically they are sharing the secret shares among each other, and collaboratively they come up with a result. And to make it a bit more interesting and a little bit more real life, let me walk you through an example. How would you, for example, calculate the average salary of 3 participants, but without sharing the actual salary of each? So this is the formula for the salary. Is the sum of the 3 salaries divided by 3, but you want to keep the salary secret. So the first instruction that we ask is to split the salary in 3 random numbers. So here the sum is -11 plus 24 plus 32 equals 45 for the blue player, and all of them do exactly the same. Then the next step is that each player is going to share 1 element of the salary with each of the other 2 players. And for example, here we see that that the red is sharing 0 with the yellow. Okay, so the 0, as you can tell, it gives you absolutely no information about the salary of the red. But interestingly enough, the sum remains the same. So the last part of the operation is that all of the 3 players are going to sum each of their 3 new numbers, and they're going to share that, and that will be the result. And the result will be exactly the same as the average of the 3 salaries. So this is with a very basic example how our solution works. And what we did at the Inpher is that we took this protocol and we expanded it. We implemented various operations, series of operations, building blocks of operations, working in the same way that allows us to do many things. Allows us to do computation of machine learning operations, and joining the data together, so making joins, making intersections of data without having to actually share the data, without taking the data out of the privacy zone. And the way it works is you have this XOR service that I showed you before in the cloud, and then you have the data that is staying within the player's privacy zone. And then we install a machine whose job is to execute the instructions from the central player. And on the left, you see that there is a portal, an analyst portal that is managed by access rights. And basically, the analyst sends the computation instruction, and collaboratively, the players come up with a result. All right. So the use case I wanted to walk you through today is something that we did with BNY Mellon. So this case you can find in much more detail in our webpage. There is a whole let's say article about it and what we did. But basically what we did with them is we did let's say a POC where they provided us with 3 sets of different data from different banks. And the premise here was, as Ivich said before, more data is better results. And what we wanted to demonstrate here is that by adding data from more banks, we get a better ROC curve. So meaning we get a model that when you run new transactions on it, it provides a better prediction in the sense that you have less false positives. So everything, all the transactions that are going to be flagged by the model are going to be, they have a better probability of being actual frauds. And that way you avoid, having to work or to investigate some transactions that at the end of the day are not useful. So the way the demo works, and there's going to be 2 parts. I'm going to demonstrate how to do vertical stacking. So, and this is what we did with BNY Mellon, meaning that you have a player with a dataset A, bank A, and dataset B with bank B, and both datasets have labels. So they already indicated which transactions should be flagged. But by joining the data from A and B, we have, let's say, we have more examples for the machine learning algorithm to build and to create the model in a more precise way. So what we first do is vertical stacking. We join the data together in a vertical way. And this works when you have data that has the same schema. Then we compute a logistic regression and we get some coefficients. So let's have a look at this exact case. So it's this one for detection. And by the way, these demos you can access. They are on our website. You just have to register for the trial. I provide the link at the end. You also have documentation. You have everything that you need to start with secret computing and understand how it works. So for detection here, we start with the GUI. And this is basically the portal from, let's say, user-friendly way, but we also have all of our instructions. They are available as a Python library. So your data scientists, they can directly call the functions from the command line, from the Python program, and they can also integrate the product with your already existing systems. Meaning if you already have a transaction monitoring system, you can use our built-in API to send and receive instructions from and to our solution. So the first thing that we do here is we select data set. So here we have the two players. We have a training data set and a testing data set. So we select the training data set. Okay. And what we want to do is we want to do a logistic regression. And we don't do an intercept here because we're really doing a logistic regression. So we select all the fields except the last one, which is our labels, which are our labels. And then we're gonna stack it with the data from B from 1 to 9, so all the same columns, right? And here we see now we have stacked the data. Then the second part is that we want to select the target. So here the same, we select A and then we select B. Then I don't have the automation tool like you, Peter. So I have to do everything by hand. And here we go. So now we have selected A and B, and we want to find what is the function in the middle. So we basically run the computation. And it's going to take a while, but basically there's going to be an MPC offline phase. There's going to be an online phase. There's going to be a phase where the players are going to start sharing the data among each other. And at the end of the day, there's going to be a result, which is basically our model. So while it's running, I show you a reminder of what it looks like. So we're going to get the matrix of the coefficients, and the number of columns should match the number of coefficients. So we go back here, it takes a bit of time. So in the meantime, I can walk you through the second example. We're not going to do it. It's going to look more or less the same. But here, basically, we have dataset A and dataset B. Actually, dataset A should not have labels. And basically, we are joining it together. So this is what we was mentioned before. It's the ability to join the data together, meaning matching the actual transactions by the transaction number or by the account number, but by doing this in a privacy preserving way, meaning that A and B never see each other's data. They never put the data together. The data never leaves the bank, and the join of the database exists in a virtual way. So at the end, here we go. So at the end of the calculation, you get a matrix of coefficient. This is really your model, and these are the weights that are applied to each of the parameters. So when you run an inference, then you take a new transaction, you multiply it by this model, and you get whether yes or no, it's potentially a fraud. So because we are already almost out of time, just want to jump back to the basically summary what we saw. Vertical stacking, so we add more data and we get a better model. And with horizontal stacking, which is the second use case that we saw, we get more features. Basically, we get more features that allow us to build a better model, and at the end of the day, also have basically a better model. So what Inpher is at the end of the day, we have this platform where we can orchestrate and customize these PETs computations. It allows you to do data sharing without actually sharing. And what we have is a robust, enterprise-ready, secure multi-party computation implementation that supports machine learning. So with that, this is the end of my presentation. Thank you very much. And if you have any questions, don't hesitate. Now is the time.
Thank you very much. Both excellent presentations, and both show that you can use the similar pieces of technology, but combine them in a different way. So it's very interesting to see different approaches that are doing very similar things. That was really interesting to see in action. And back to your call for questions, Manuel. We still have a few minutes for a question, and I think we have a general question from our expert group. So we will use this opportunity because we have here people in the room in Munich. And the question is from Maria.
Maria Komisarova, yes, hello, I'm from Raiffeisen Bank. So my question is the following. Today we saw the two technologies, which are quite interesting, but what I can't get, frankly speaking, maybe you can help me, I figure out. For example, we have, in addition, federative learning model. Why it's not in place? Do you plan to test it to solve the same task? And what the main difference, for example, with the technology that we currently saw with multi-party computing and the technology which give us this possibility to calculate in the federative mode.
Mm-hmm.
Sorry.
So is, to whom is the question?
I think that to Manuel, first of all, because I see, frankly speaking, from my side, I'm right now just start to dig in deeper into details into these topics, and for me, just interesting to understand what the main maybe advantages of the multi-party computing compared with federative model, and where federative learning, and where we can use the one technology and another, because there looks from my side quite similar on the one hand. On the other hand, there are some difference, and the question where it's more useful to use one technology and where it's better to use another one.
Mm-hmm.
Okay, hi Maria. So the advantage of SMPC is that we are not sending the data. We're not sending any data outside of the bank. So all the data stays inside of the confidentiality perimeter. The only thing that is coming out are these secret shares, which are, as you saw in the demonstration, they are impossible to decrypt, even if you have infinite computer power. So really, I would say these are the main two advantages. It's impossible to decrypt, even with infinite computer power. And two, you don't have to send the data anywhere. The data stays inside of the confidentiality perimeter.
Mm-hmm. Sorry, just for clarification, but when I read about this federative learning, it looks similar. So you don't need to send the real data, you send just the result of the model, like weights or something like that. Yeah,
yes.
Real data as well. So
yes, so federated learning, you are sending the models, and then it requires an additional step, which is called secure aggregation, that we are performing using also MPC. Because even if you are only sending the models, still the models are giving away some information. But for the purpose of I mean, the way that we use it is that at the end of the federated learning process, we send the weights, and then the weights are aggregated using MPC, using secure aggregation.
Mm-hmm.
okay.
Is to make it even more secure.
So federated learning has some weaknesses from the privacy point of view that can be solved by, for example, by
combining with MPC.
Also, and also Peter also showed how you can combine in his approach two different technologies.
No? Yeah, that's I understood as well. Yeah. Mm-hmm. So is my understanding correct that this secure multi-party computing is the most secured way how we can collaborate between the organization?
One more remark about your question. So Maria, so when you have federated learning, it usually works when you have the data with the same schema in all the banks. So all the data must have the same columns. Okay.
Okay.
With MPC, what you can do is you can join data from databases with different features. So let's say bank A provides the name and the transaction amount and from bank and to account, from account and to account. And then bank B provides, for example, only one information that is the credit scoring, for example. Yeah. Or it would have to provide more data actually to make it really secure. But let's say that they don't have to share the same type of information.
Okay.
So with MPC here, you are doing this horizontal stacking, that you are joining data about the same transaction across different players or about the same customer across different players. Whereas the federated learning, each player is uploading a version of their data, let's say examples of their data, so that collaborative, they can build a better model.
Okay, understood. Yeah, thank you.
Thank you for your question. Peter, would you like to add anything to Manuel's answer?
Well, I think he said it well, so there's not a whole lot to add. If I'd have to add something, I'd say with MPC you have a choice of which security model you want to abide by. Typically, we make a distinction between passive security, covert security, and active security. Passive being the lowest level of security, where you assume everyone abides by the protocol. So that way you can come up with an efficient protocol, but it only works if everyone agrees to follow the protocol to the letter. You can also protect against people deviating from the protocol, then you need active security. The downside of choosing active security is that it's more computationally expensive. So there's lots of choices we can make to come up with an efficient protocol if we know where we can cut some corners. But because we have some agreements between the companies, if we trust another company to some extent, we can come up with a more efficient protocol. But in general, I would say it's true that with MPC, it is at least possible to make a protocol that's very secure and only exposes the end result. And of course, you have to be wary about information that can be deduced from the end result. So if Manuel and I were to calculate our average salary, afterwards, I would probably know Manuel's salary. So that wouldn't be useful, but
only because we are two players.
Exactly.
So but if there would be many more players, it would be fine. And I would say it's not necessarily about the number of players, but also the number of features that are secret shared. So if you are secret sharing only one feature, and I give you all the other features and we compute the result together, then immediately I can guess what was your feature. Like you have two sides of a sum. If you give me the total, I guess your side. But if you have multiple, I would say, features, then it would be harder for me to guess all of them.
Yeah. So that being said, is your input always secure when you've used MPC? No, but you do ensure that the only thing another party learns in a direct sense is the output.
And this is why it's important also, as we mentioned earlier, that you have to have this governance to make sure that every time you are doing an inference, to understand exactly what data you are requesting to the model, and somebody has to make sure that this stays secure. Yeah. Because it's very easy to say something that gets wrong.
Yeah. So in this moment we are already 6 minutes over time. I didn't want to stop because I enjoyed the discussion. It became a bit more and more technical as our event continued, but I think that's okay. This is an important part of this equation is the technical solution. But I still want to remind you that especially there are very important things that we'll discuss also, which are not technical, but it's about how to start the initiative, how to get the different partners on board, and to share the same vision to use this privacy preserving technology to improve your results, whatever they are. I want to thank to speakers, to presenters, to Peter, to Manuel, and to Ivich, and also to LinkedIn Live participants. that were attending this event, and we will share this event, the video of the full event. And thank you very much and have a nice afternoon. Goodbye from
Thank you very much. Thank you. Goodbye, everyone.
Goodbye.